Today we're going to take a look at the effects of changing the dimensions of your three-dimensional figure. So first we're going to take a look at the cube on the right here, and we're going to think about what the surface area of my cube would be and what the volume would be if our cube has a side length of 2 inches. So we know if we have a side length of 2 inches, we are 2 inches by 2 inches by 2 inches. What would my surface area be? Well, we know that our cube, the face of that, has an area of 4 square inches, right? How many faces do we have? Well, on a cube there are 6. So 4 square inches, we have 6 faces. This surface area is going to have to be, well, let's call it inches, sorry, 24 square inches. What about the volume? Well, volume, this is pretty easy. This is a box. We would just have length times width times height. So we would do 2 times 2 times 2. So let's think about that. 2 times 2 times 2. Our volume would be 8 cubic inches. Okay. Looks good. In the second part, it says the side length of the cube is now tripled. What is the new surface area and what is the new volume? So if my side length is tripled times by 3, this would now be 6 by 6 by 6. Well, so one face, 6 times 6 would be 36. And if we take here one face, 36, and multiply it by 6, we would find we would have a surface area of 216 square inches. Question 4 asks about the volume. Well, my volume would be 6 times 6 times 6. Well, ironically enough, that also comes out to 216, but that's in cubic inches, so that's something much different. Okay, step number 5. It says, well, right above that, it says divide the answer in number 3 by the answer in number 1. So we're wanting to compare our surface areas and to see what we noticed. So if we take, we're looking at our purple numbers here, 216 square inches divided by 24 square inches, we're going to see that we get 9. What do you notice about how the surface area changed when the sides were tripled? Well, what do we notice about sides tripled? My surface area changed by a factor of 9. Well, 9 is 3 squared, right? Divide the answer in number 4 by the answer in number 2. Well, if I take my volume, 216, and I divide by 8, we actually get 27. So my sides were tripled, but my volume increased by a factor of 27. Well, 27 is 3 cubed. In fact, that's always going to be the case. When my dimensions change by a factor of 3, my surface area is always going to change by that factor of 3 squared. And my volume would always change by the factor of 3 cubed. And that doesn't matter what the number would be, but those changes will always happen. The surface area changes by the factor squared. The volume changes by the factor cubed. So we had talked about this earlier in the year. In fact, we talked a little bit about it in chapter 10. Now we're adding it to the volume. If you look down below, I have the chart at the bottom that's trying to kind of summarize what happens when you change your dimensions proportionally. Meaning you're changing all your dimensions, not just one. Well, if your dimensions change by a factor of A, your surface area changes by a factor and your volume is going to change by a factor of a cubed. So if we say we had a box and we doubled the length with height, we doubled the dimensions, my surface area would quadruple, but my volume would actually increase times by 8, because this would be 2 squared and this would be 2 cubed. And that is always going to be the case when you change your dimensions proportionally. Okay, if you have further questions on this, please stop in and see me.